Let's in fact look at an example of how we might use these expressions to help us solve problems. So let's suppose that theta is in the third quadrant and the sine of theta is 3 over 5. It should be minus 3 over 5 since we're in the third quadrant. Let's go ahead and find the cosine of theta. This is a simple example. Things can get more complicated where we can be working with other kinds of trig functions, but this is a general problem. We're given a particular trig function, has a particular value in a particular quadrant, and we're asked to find some other trig function. I would start with the Pythagorean identity here. The sine squared of theta plus the cosine squared of theta equals 1. And we can plug in our values here. We know that the sine of theta is minus 3/5, and we have the sine of theta squared plus the cosine squared of theta must equal 1. So minus 3/5 squared will be the same as positive 9/25. So 9/25 plus the cosine squared of theta is equal to 1. And I'm going to, in anticipation of my next move, write 1 as 25/25. If we subtract the 9/25 from both sides, we end up with the statement that the cosine squared of our angle must equal 25/25 minus 9/25, which works out to be 16/25. To solve this problem, we would simply take the square root of both sides. Remember that when we take the square root in a problem that did not have a square root previously, we should include a possibility that our result will be either positive or negative. So in this case, the cosine of theta is equal to plus or minus the square root of 16 over 25. And the square root of 16 is 4, the square root of 25 is 5. So our answer here is either plus 4/5 or minus 4/5. How do we determine which one? The key here is to look at the quadrant, right? In the third quadrant, cosine of theta should be negative. And so what we should be doing here is taking the negative root. So our answer here should be that the cosine of theta is minus 4/5. Okay. Now you might say that's a lot of trouble just for one trig function answer. Wouldn't it be much easier for me to do this on my calculator? And you certainly can go through and do this on your calculator. Of course, you have to be careful about what answer or what quadrant your final answer is in, simply because your calculator, as we talked about last chapter, will only return certain values. However, oftentimes we're interested in an exact value, and in this particular case, we have a nice exact value. We're able to come up with that relatively easily. We do have some other identities that don't get used quite so often. They go by the name of symmetry identities, and they make use of connections between values at various points on trig functions, primarily the fact that our trig functions are periodic, so we can make use of those. So for example, the sine of x plus 360n will equal always the sine of x. What this is simply saying is if we add n periods, 360 degrees, recall, is our period in degrees. If we add in n periods, we're still going to be right back where we started. The same is true for cosine. If we take and add in any number of whole periods onto cosine, we simply return back to cosine. And there are several other symmetry identities that you can look up. They don't show up very often. I won't go over them since our time is short here. The last set of identities I want to look at, however, are what are called opposite angle identities. These are another set of identities that we can derive, and we'll see that we will spend a bit of time in this chapter deriving identities. For some people this seems a lot like proofs. We will derive some identities here. So let me once again take a look at the unit circle. And in this particular case I'm going to be interested in an angle, say some angle theta, and the negative of that angle, so minus theta. And I'm going to be interested in the values of sine and cosine at these values. And in particular their relationship, so the relationship between values at these angles. Let's focus for a second on the sine of minus theta. The sine of minus theta, recall, because we're talking about sine, we're talking about the y coordinate here. The y coordinate of this particular value, this would be this right here is the sine of minus theta, and you can see that the sine of minus theta in this particular case, the way I have things drawn, will end up being negative. But you should also be able to see that it's going to be equal and opposite to the sine value that we have here, right? Which is simply the sine of theta. What this tells us then is that if we take the sine of a negative angle, that's the same as if we had the opposite sine to the sine of that angle. It gets a little confusing there with the word sine, I know. This has to do with the fact that the sine function is an odd function. If you go back and think about our even and odd functions, refer back to a graph of the sine function, you'll see that this is an odd function, and this is one of the behaviors of an odd function. So this is the opposite angle identity for sine. The opposite angle identity for cosine looks a little bit different. If I take the cosine of a negative angle, that's going to be this value right here, right? The cosine value is the x-coordinate on the unit circle. And notice that that's the same whether I'm talking about a negative angle or a positive angle. Both of these are going to have exactly the same value. So here we would say that the cosine of a negative angle is the same as the cosine of the positive angle. Sine values, sines plus or minus, do not affect the value we get when we evaluate the cosine of a function. And that has to do with the fact that the cosine is an even function. Again, if you look at the graph of cosine, cosine is symmetric with respect to the y-axis. That makes it an even function, and this is a property of even functions. So this is a good introduction to identities. There are quite a few identities for us to see throughout this chapter. We've looked at just a few of them. However, again, the Pythagorean identities in particular are very important. The work that will be assigned for this particular section of the book seems rather long, but it is an excellent introduction and will make you a stronger person. We will begin looking at this work in class next time we meet.